So now we start part 4 of this lecture. And I want to remind ourselves that what we did at the end of part 3 was compare the rate of return that we might expect to get from two investment strategies. One was to buy a long-term bond and hold it all the way to maturity, in which case we receive a known rate of return, which is the yield on that longer term bond, in this case, a 2-period bond. And we said we could compare that yield to the expected rate of return we would get in logs from buying short-term bonds, holding them for one period, and then rolling them over, buying another one next period when this one matures, and holding that for one period. And we use that to say, oh, that rate of return is an average of the yields this period and expected next period on the short-term bond. And we now want to compare this rate of return to this rate of return, which is what you get from these two different investment strategies. And in that comparison, we define something we call the term premium. So the term premium is the difference in the rate of return between these two strategies. So I'm going to use this notation here to define the term premium on a 2-period bond at time t. And what that is at time t, I can see the yield on a 2-period bond. That's the rate of return I would get from buying the 2-period bond and holding it until maturity for 2 periods. And I compare that to the average of the current yield on the 1-period bond and the expected value of the yield on the 1-period bond 1 period from now. And so the difference between these two rates of return that we get from these two different investment strategies, I'm defining as the term premium right here. And for longer maturities, I'm doing it in the logically similar way. I'm saying we can compare the yield on an n-period bond, maybe a 20-year bond, with the average of the 1-period yields that we would expect to earn as of time t for all the time periods up till a bond that matures, rolling it over every period until it matures n periods from now. Now, one thing to observe about the term premium is that this is not something we can directly measure in data. We do know this yield. We see it today, the yield on a longer term bond. We do know this number, the yield on a 1-period bond. What we don't know is what do people expect the yield on the 1-period bond is going to be in the future. Similarly, this problem gets more difficult as we go further and further out in the future when we look at the term premium on longer term bonds. So we can't really directly measure this. So we're going to have to talk about, how do we think about what this term premium is, and how might we come up with proxies for measuring what it might be? Okay, now you could think about, well, what's the term premium on average? If you look over a long period of time, what is the difference between the yields on short-term on 2-period bonds with the average of yields on 1-period bonds today and expected in the future? So this is what we defined as the term premium today. If you look at data on yields over a long period of time, presumably what we're seeing is the unconditional expectation, or the expectation over a long period of time, of term premia. So notice that this expectation sign does not have a sub t, meaning it's not a conditional expectation, it's an unconditional expectation, or the long run average of the 2-period yield would be 1/2 the long run average of the 1-period yield plus the long run average of our conditional expectation of the 1 period yield 1 period from now. And by the law of iterated expectations, this itself is just the unconditional expectation of the 1 period yield. So this formula, when we take unconditional expectations, can be written this way. The long run average or unconditional expectation of the term premium is just the long run average of the 2 period yield minus the long run average of the 1 period yield, because this is 1/2 unconditional expectation plus unconditional expectation. This is the same term. So the 2 and the 1/2 cancel, and that's why we get this expression. And more generally, for longer maturities, we have the same thing. On average, the term premium is just the difference between the unconditional average of the longer maturity yield and the unconditional average of the shorter maturity yield. So this tells us about a relationship between term premia on average and what we call the slope of the term structure on average, or the differences between yields of different maturities on average. Okay. And then we have this concept, I mentioned it before, called the expectations hypothesis of the term structure. And that hypothesis, there's a strong version of it, which is that all term premia are 0. And then there's a weaker form of it, which is what we're going to use in this course, which is that the term premia don't vary over time. So if you go back 2 slides, I defined term premia with a subscript because expectations at time t might change, events might change, the difference between this and this can change. So this is something conceptually that could vary over time. The expectations hypothesis of the term structure is a hypothesis or a model that assumes that these term premia are constants that do not vary over time. So that's a structure that the model imposes on the data, and it's a structure that we might try to evaluate whether it's true or not. Okay, but this gets us to data that we might use to think about term premia, which is what I mentioned, yield spreads. What actually is the difference on average, or at any point in time, and on average between longer maturity yields and shorter maturity yields? How do yield spreads differ with maturity, and how do they move over time? And you're going to construct pictures that I'm about to show you in the homework. So on average, yield spreads are positive. What I'm showing in this graph using the 0 coupon data is the difference between the yield on a 2 period, 3 period, 4 period, 5 period, 6 period bond, 7 period bond relative to a 1 period bond. I'm always a 1 year bond. I'm always subtracting off the 1 year bond. And so here's 0. So we see most of the time these yield spreads are positive, and the further out you go in maturity, this is going from 2 to 7 years versus the 1 year bond, the bigger the yield spread gets. So the term structure is typically yields are upward sloping typically, and then sometimes they're very flat, and sometimes they're downward sloping. So we talked about that. Here it's very steeply downward sloping. And this is a time when the yield curve is quite flat. This is a time when the yield curve is quite steeply upward sloping, because you notice these differences are quite large. And if we go further out, so this is now the yield spread of 10 years minus 1 year, 20 years minus 1 year, 30 years minus 1 year, we get this picture. As we mentioned before, since the 10-year, the 20-year, and the 30-year yields all move pretty much together, then of course their differences versus the 1 year yield also move pretty much together. And we get this picture here. And these movements in the steepness, or how big the spread is what's called the slope factor in the term structure. So we had the level factor, to what extent the yields of all maturities move up and down together, and then we have the slope factor, how much does the difference between long-term and short-term yields move over time, and here we see a picture of that moving over time. So we'll stop here and start up with a more detailed discussion of the expectations hypothesis of the term structure in the next part.